To solve this equation, we want to first isolate the logarithm. So we need to subtract 2 on both sides. We get log base 3 of x plus 1 equals 3. After we've isolated the log, we want to convert this to its equivalent exponential form. To do that, we take the base, raise it to the third power, and set that equal to the argument. 3 cubed equals x plus 1. 3 cubed is 27. 27 equals x plus 1. Subtract 1, and we get that x is 26. Since we started with a logarithmic equation, we do want to check our solution to make sure it's not extraneous. So in the calculator, go to the original equation, 2 plus log base 3. We can go to the math key and then scroll up to log base. We want the base to be 3 and x plus 1. X we think is 26, so we'll type in 26, add 1, and hopefully this is equal to 5. It is, so we know our solution is correct. To solve this equation, we again need to isolate the logarithm. So we'll subtract 1 on both sides. And we now have the natural log of e to the negative 2x equals 6. We'll learn some shortcuts for this later, but for now, let's think of this as log base e of e raised to the negative 2x equals 6. Remember that the natural log is really log base e. Now we'll convert this logarithmic equation into exponential form. To do that, we take the base of the log, raise it to the 6th power, and set that equal to the argument on the log. So e raised to the 6th power equals e to the negative 2x. Now recognize that we have powers of the same base. E to the 6 equals e to the negative 2x. We can simply ignore the base and set the exponents equal. So 6 equals negative 2x. And then divide by negative 2, we get that x is negative 3. To check this, we can go to the calculator and we'll type in the original equation, 1 plus the natural log of e raised to the negative 2 times x, which we think is negative 3. And hopefully this will give us 7. It does, so we know that our solution, negative 3, is correct. This time we're starting with an exponential equation. To solve this, we want to convert it to its equivalent logarithmic form. The base of the exponential will be the base of the log that we use. So the base of the exponential is e. That means the base of the log is e. So we have the natural log of 13 equals the power negative 2x plus 1. Now to solve this, we will subtract 1 on both sides. Natural log of 13 minus 1 equals negative 2x. Divide both sides by negative 2. And we get natural log of 13 minus 1 over negative 2 is equal to x. So to check this, we'll go to the calculator. Typing in the original equation, we have second e. That's raised to the negative 2 times x. Since x is a fraction, I'm going to put that in parentheses and use the alpha y equals number 1 to get that fraction. Now we'll type in the natural log of 13 minus 1 all over negative 2. Jump out of that parenthesis. Then we have plus 1, still in the exponent. And this should give us 13. It does, so we know that our answer is correct. In our final example, we have an exponential equation which we again need to first isolate the exponential expression. To do that, we'll divide both sides by 4, leaving us with e to the x plus 1 equals 5/4. Once you've isolated the exponential, we convert it to its equivalent logarithmic form, which is the natural log of 5/4 equals x plus 1. From here, to isolate the x, we will subtract 1 on both sides, leaving us with the natural log of 5/4 minus 1 equals x. From here, we can check using the calculator. 4 times e raised to the x, which we think is the natural log of 5/4 minus 1, and then still in the exponent plus 1. This gives us 5, which confirms our answer is correct.